Okay, so we were dealing with this median finding algorithm. Okay. Not median finding, we were talking about this ith smallest element, and we have discussed that median is also one smallest, ith smallest element finding algorithm. And we have seen that, okay, the main idea is to find out a good pivot. Okay. So good pivot element we have to find out, a good pivot. And for finding out the good pivot, what we have done is we have subdivided the whole list of numbers into groups of 5. Okay. And then each group we have insertion sort. And then we have extracted the medians of that. And then those medians will be recursively solved to find out the median. Again, the median of medians. Okay. Again, those medians will be extracted, and then again recursively we have to find out the median of those medians. So ultimately we will be finding one element which we are calling the median of median, and that we are claiming that that particular element, if I am considering as a pivot, then we may have almost 30:70 split, almost near about that. So that claim we will be right now seeing. Okay. So the first thing is that this you see that we are having this group considered. Okay, these groups, right? So these groups are considered, and as these arrows telling that we are going from greater to lesser. Okay, so this arrow, so this x might be say 100. If this is 100, then this could be say maybe one number between 1 to 99. Okay, so this could be maybe 50, this could be maybe 40. As this is insertion sorted, we can think of like that. Okay, so this is the case that, well, this guy x, if it is 100, so this is having this arrow, so that means this is greater to lesser, and this guy will be having arrow like this, so this could be greater to lesser. So by following this logic, what we can say is that at least, and okay, before leaving this slide, this is again this, we are taking this slide from this Eric Diemen and Lyserson 2005 course. Okay, so at least half of the group of medians, half of the group medians are less equal to x. Okay, are less equal to x. So you see this, whenever I am having this, this is, I am finding the median of medians. Okay, median of medians. So we can think of, so whenever I am trying to find out this, extracting these elements, then again I am finding the median. So again this will be sorted. So this is, in this way the arrow will be there, in this way the arrow will be there, and in this way the arrow will be there, right? So this is signifying that all these elements are less than this x. Okay, and all these elements are also less than this x, right? And now one observation is that if this guy is less than this x, then as this group is sorted, insertion sorted, so then definitely this guy and this guy will be less than this. Okay, and then if this guy and this guy less than this, then definitely this and this will be less than this. Okay, as this is less than this. So by the transitive relationship, we will be having all these three elements here will be less than this elements x. Okay. Similarly, this will be the case. All these elements will be less than this, less equal to this. All these elements will be less equal to this, right? And these elements less equal to this x. Okay. So that is what exactly is written here. At least half the group of medians are less equal to x. That means this one, okay, and this one. So half the group of the medians are less equal to this x, right? So this half the groups, that means how many groups we are having? If I am having n elements altogether, so all these elements, how many elements we are having? Maybe 44. Okay. So n maybe here 44 elements. Then how many such groups we will be having? How many such groups? N by 5. Then we can take floor. So what will be the value? So n by 4. So this 44 by 5, and if I am taking floor, what will be the value? Who will be telling? What will be the value? Who will be telling? Nobody listening? Hello? Tell me. 44 by 5 floor. What will be the value here? 8. So 8. As you are seeing this 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we are even to have it safe in the analysis, we are excluding these many number of elements, 4 elements or 2 elements or 3 elements, whatever will be there. So at least we are going by this at least scenario. Okay. So this n by 5, this many, then this 8 divide by 2, then again I am taking the floor to have a safety, then we are having 4 in this case. Okay. So four groups of medians, four groups, which each one contributing one median. That means 4 medians will be less equal to x. If 4 medians are less equal to x, then all these elements we are having that all these elements will be less equal to this x. Okay. So that will be in the next slide. We will be writing that. So at least these many groups of medians will be less equal to x, which is coming as n by 10 floor. Okay. N by 10 floor. So this is 5 times 2. So this is 10. N by 10 floor is 4 floor groups of medians we will be having, which will be less equal to this x. And you see this, whenever I am telling that all these medians are less equal to this x, then we are sure that at least 3 elements from each group, each group will be less equal to x. So that's why these many number of groups we are having, and each group will be contributing 3 elements. Each group will be contributing 3 elements, right, which will be less equal to this x. So 3 times these many number of groups, those many elements will be less equal to x. That means this element, this element, this element, this element, this element, this element, and so on. Okay. So for this portion, so we are sure that these many elements will be less equal to x. That means if I am subdividing around this x, I am subdividing, then these many elements will be in one side. Okay. So similarly, if I am taking this group, this portion, so this portion, so this is, as this is sorted, okay, so that means from greater to lesser we are having this arrow. Okay. So this x will be less equal to this, and this will be in this side, right? So now if I am considering this one, so what will be the property of, if I am considering this portion, then what will be the property of this element and this x? Who will be telling? Who will be telling? What will be the property of this element, this particular element and this x? Who will be telling? Saurabh, you tell me. What will be the relationship of this element with this element x? Who will be telling? Greater than. So as this is greater than this, and this is sorted, this group, so definitely this guy is greater than this. So via transitive relationship we will be having this guy is greater than this, okay, greater equals to, we can say. Okay, so at least these many elements, similar with the similar logic that we have put forward here, with the similar logic we can say that these many elements are greater equals to x as well. Okay, so what we can do here, some simplification if we are doing, then our analysis will be much more easier. Then for n greater equals to 50, so for n greater equals to 50 some number, then we can prove maybe by induction that this 3 times n by 10 floor is greater equals to n by 4. N by 10 is greater equals to n by 4. Okay. So if I am putting the value 50 here, what will be this case? 50 by 10, what will be the value? So 5, so this is 5 times 3, so this is 15. What will be the value of n by 4? So 12.5. Yes. So you see that for n greater equals to 50, this asymptotic relationship is holding. 15 greater equals to this 12.5. Okay. So this we can write this for n greater equals to 50. Now if you ask me a question that how did you get that this should be n greater equals to 50? So I'll be telling that maybe by this trial and error, okay, and some intuitive guess. Okay. So this in 3 times this, as this floor is little bit annoying, okay, so as soon as possible I'm removing this floor, okay, so it is greater equals to n by 4. Okay, so we are telling that if I am considering this x and if I am considering this portion, all this portion, right, then I am telling that if around this pivot, right, so around this pivot what we have got, that at least these many elements will be this 3 times this n by 10 floor. These many elements will be less equal to x, less equal to x. So if I am partitioning the, if I am taking that x as the pivot, that x as the pivot, then what will be the scenario? Then around this x, if I am comparing all the elements we are having, then we can ensure that okay, these many elements will be less equal to this, right? So these many elements will be greater than this, okay, at least. So it must be there, okay. These many elements must be there in the left hand side, right? And these many elements also will be must be there in the right hand side. That also we have to ensure that in both the partition we are having this kind of elements, okay. Now with simplification, what we are getting that this is greater equals to that. That means that if this is giving 15, then this is giving 12.5, okay, 12.5. That means we are telling that okay, if n equal to 50, then 12.5, so 12 elements at least will be there in this side, at least will be there in this side, right? 12 elements. So this is greater equals to n by 4. So at least 12.5 or more, okay, or more elements will be there. So at least this many elements, n by 4. If I am going with this lower bound, n by 4 only, then we are ensuring okay, if I am having 50 elements, then 12 elements must be there in one side, right? And then 12 elements are there, then these 38 elements will be in this side. So definitely we are having a good partition. We are having a good partition, right? So this is what we had to prove here, this argument. So now therefore this for n greater equals to 50, the recursive call to select in step 4 is executed recursively on less equal to 3n by 4 elements. So how many elements? If I am ensuring that in one side n by 4 elements will be there, n by 4 elements, then in other side how many elements will be there? We had n elements, and then in one side we are having n by 4 elements, okay. So this is greater equals to, so this will be less equal to, right? So this is 3n by 4 elements, 3n by 4 elements, right? So 3n by 4 elements we are having in another side, okay. So this 3n by 4, that will be that is the upper bound. 3n by 4 less equal to 3n by 4. And say for our safety purpose, I am assuming, okay, let us suppose that this is 3n by 4. That is the maximum possible in one side. Maximum possible in one side. Even if I am going with this, every time I am recursing in the larger part, that is 3n by 4, then also we will be having a good or our desired running time analysis, Tn will be equals to order of n. That we have to show right now. So the whole idea right now, we can say that okay, what we have done, we had a list, okay, we had a list and we have found a pivot. We have found a pivot by finding the median of medians, and around which we have partition, and that partition is telling that in one side at most 3n by 4 elements will be there, at most, okay, no more than that, no matter how you try, okay. You cannot fool that median of medians, okay, by that. So 3n by 4 elements will be there in one side at most. And if somebody is telling, okay, we are doing some kind of worst case analysis, so always I'll be taking the larger part, that means the 3n by 4 part as the process we are taking for recursive calling. Okay, so this part, this is the larger part, and which is 3n by 4 elements. So we will be going with that, and we will be showing that, okay, even if we are getting a good result. So this is the so far idea we have got, right? And now this is we are developing a recurrence here. So this select ith smallest element from n elements. Select ith smallest element from n elements. And we have to divide the n elements into groups of 5. So that dividing will be taking how much amount of time, how many such groups we have to create, how many such groups, n by 5 groups. So that will be taking theta n time. So here you see in the binary search, we had a divide operation trivial. In merge sort, we had a divide operation trivial. But here you see that divide operation here is taking theta n time. Because we need to have n by 5 number of groups. Okay. Or order of n by 5 number of groups. So that means we need this theta n time. And then what we got to do? We have to recursively select the median x of the n by 5 floor group medians to be the pivot. Okay. So after dividing it into groups of 5, then we have to extract the median. Then again we have to recursively call this select to find the median of medians. Okay. So that means that will be taking Tn by 5, that is the recursive cost. Okay. And then what we are doing after finding this pivot element, we have to partition the whole list. This is the list we are having. So with so many points we are having, and we have found the pivot element, and then for each of these element will have to be compared with this pivot, and then we will be having a division of the list like this. Okay. So that comparison and partitioning will be definitely taking theta n time, because theta n number of comparisons will be there. And then again what we got to do is we have got this partition, and then we have seen that first of all we have to check that I equals to k or not. Okay. So k is the number of elements which are there, or k is the rank of this particular pivot element. Whether I equals to k or not, if k is 4, we have seen I is 7 and k is 4 in the last class. So whether I equals to k or not, I equal to 7, I may be equal to 4 also, fourth smallest, then we have to return this I equals to k. Else if I less than k, then we have to recursively call select for the ith smallest element in the lower part. So this part, lower part we have to do, or left hand side part. Else we have to recursively select I minus kth smallest element in the upper part, or this right hand side part. That we have seen in the last class. And that thing in that, whenever we are recursively will be calling, what will be the size of this lower part or upper part? That could be at most 3n by 4. That we have argued in our analysis. Okay. So if I combine this this, then we will be having the overall running time Tn, that will be equals to Tn by 5 plus T3n by 3n by 4 and 3n by 4. So Tn by 5 will be there, T3n by 4 will be there, okay, and then this theta n will be there, and then this theta n will be there. So theta n plus theta n, so that will be theta n again. So we have written theta n. Now what we can do is we can use our substitution method to solve this. Okay, substitution method. We know how to solve this. So our target is that we have to prove that Tn equal to order of n. Tn equal to order of n. So this guess is Tn equal to order of n. Tn equal to order of n, that is the guess. And so we have to prove that Tn less equal to C times n. So it is there. Tn, we have to prove that Tn less equal to Cn. That is coming from this guess. Okay, and this is from the definition of order notation. Okay, so now what we got to do, we have to assume that it is true for some lower values of n. That means which one will be the lower value? So n by 5, because that we have to substitute in terms of n. So it is true for Tn by 5. That means Tn by 5, that is less equal to C times n by 5. And then T3n by 4, we have to assume also that it is true for this 3n by 4 lower values of n. So C times 3n by 4. So now we have to prove that it is true for n. So we have to go by this Tn equal to this, and then this is less equal to Cn by 5, that means 1 by 5 Cn, 3n by 4, that means 3 by 4 Cn, 3 by 4 Cn, and then plus theta n. So this theta n will be there. So this is 19 by 20 Cn plus this theta n. And you know this, we have already shown you that how to do this. So theta n means we have to substitute it by its upper bound, that is less equal to dn. So Cn, so this will be this again, this 19 by 20 Cn, I am writing as Cn minus 1 by 20 Cn. That we can do, right? And that is exactly is done here. And then plus this dn is there, dn or theta n is there. So Cn minus this 1 by 20 Cn minus dn. So that is exactly written here. Okay, so this theta n is upper bounded by this dn. Okay, so 1 by 20 Cn minus dn. So this will be less equal to Cn whenever this 1 by 20 Cn minus dn, that is greater equals to 0, right? So this is Cn minus, so throughout if I multiply by 20, Cn minus maybe this 20 dn greater equals to 0, right? I am multiplying throughout by 20. 20 will be cancelled from here, and then I am dividing throughout by n. So it will be C minus 20d greater equals to 0. Then C will be greater equals to 20d. So whatever d value I will be choosing here, that times 20 constant value I have to take for overall constant C. Overall constant C, or this is okay. and then if I am taking that liberty I am having. So if I am taking that, then this condition will be satisfied. That means this is less equal to this Cn. Okay. So now we can say that our guess is true. Our guess, we have got this guess and this is true. We have proved this. So this is the guess we had and we have proved this. Okay. So this implementation you must be doing. Okay. This is a mandatory coding exercise. This algorithm, mandatory. Okay. Everybody, in the next class, I may call in the next week, Tuesday's class, Monday class. Next week, Monday, what I'll be doing is I can select any one of you and you will be presenting with that code. So this is a mandatory coding exercise that you must have to implement. Okay, this ith smallest element, and algorithm that I have shown you, these groups of 5 with that only. Okay, if somebody is telling, okay, I have sorted the list and then index position I am returning, no. If somebody is telling I am randomly choosing the pivot and then partitioning and then doing the trick, no. This implementation you have to do. I will be suggesting that you should be doing yourself first. You should try it yourself first, and then you should be going to the internet for solution. At the worst case, you should be going to the internet. Otherwise, you should do it yourself. Then only you can learn coding. Otherwise, not. So right now the tendency is that if somebody is giving you the code, almost all the time we go to the internet and we download the code and try to run it. That should not be happening. That should not be happening. And you see, there are lots of websites now have introduced the concept of badge. Okay, you are getting the badge. Say Stack Exchange, say other websites, maybe this Quora, maybe others. Okay, they are introducing the badges. That means those who will be contributing afresh for something. If somebody is posting some questions and you are giving the first time you are giving the solution, you will be much more closer to getting the badge. And if you are getting the badge, then what will be the benefit you will be getting? Maybe if some companies who will be hiring, the company will be hiring those guys who are having the badge. So mind you that copying, pasting and running will not be a good solution in the long run. You may pass this exam, but it may not be good for your career. So that's why you should not be going to the internet first and you should be downloading the code and you should be running. That is not the case. You should try first yourself, and then if any doubt is coming, then you can see others implementation. But also seeing others implementation, you should be coming back and you should be running your code yourself, whatever code you have written, not the copied code. Okay, so today up to this, and if you have any question you can ask me, but first